Consider this. In 1918, a devastating influenza pandemic swept across the globe, a microscopic invader that brought the world to its knees. It was a time of immense fear and uncertainty as this new strain of flu proved to be extraordinarily deadly. But amidst the tragedy, something remarkable happened. Millions of people who were exposed to the virus never got sick. The answer wasn't luck. It was something deep inside them, a silent, powerful force working tirelessly to protect them. Think about that for a moment. An invisible army, stationed within every single one of us, waged a war against an equally invisible enemy and won. This story isn't just a historical footnote, it's a testament to the incredible power humming within your own body right now, at this very second. So what exactly is this immune system? Let's break it down. Imagine your body is a bustling high-tech city. Power plants, your mitochondria, a transportation network, your circulatory system, a central government, your brain. Like any valuable city, it needs a top-notch security system to protect its citizens, your cells, from troublemakers. This security team is your immune system. It's not just one thing, it's a whole crew of specialized units. Guards, detectives, soldiers, intelligence agents, all with one mission: identify and eliminate threats before they cause real damage. This team is made of many types of white blood cells, the boots on the ground. Think of them as different units in a police force: city walls, your skin and mucous membranes. But what about more sophisticated threats? For that, you have the detectives and special forces, the lymphocytes. Now for the really cool part. How does this security team know who to attack? Your body is made of trillions of your own cells, all doing their jobs, and it's surrounded by trillions of foreign microbes. If your immune system were to make a mistake and attack your own cells, that would be a disaster. It's a question that stumped scientists for decades. There are millions, perhaps even billions, of viruses, bacteria, fungi, each with a unique shape and structure. It would be impossible to have a pre-programmed instruction for every single one. The system had to be smarter, more adaptable, and more efficient than that. Instead, the body needed a system that could recognize a brand new threat it had never encountered before, and then mount a custom-built defense against it. This is where the true genius of evolution shines. The solution is so elegant, so powerful, that it feels like something out of science fiction. It's a process that allows your body to have a potential weapon ready for virtually any enemy, even enemies that haven't evolved yet. It's a system of near infinite potential, waiting for the right trigger. So, what is this hidden mechanism? The answer to this grand puzzle is a beautiful idea called the clonal selection theory. Now that sounds complicated, but the concept is surprisingly simple and elegant. Instead of pre-making a key for every possible lock, what if you generated millions of random keys? Most would be useless, but somewhere in the pile by chance, one key perfectly fits the lock on an invading germ. This is what your body does with B cells, immune detectives. Before exposure, your body creates a massive, diverse army of B cells. Each B cell has a unique receptor, like a specific key. They float around, waiting. Most never meet their match and fade away. Now, a new virus enters, call it virus X. It bumps into B cell number 1. No match. B cell number 2. No match. On and on. Then finally it bumps into B cell number 8,388,608. And click. The receptor is a perfect fit for a protein on virus X. The moment of recognition. Clonal selection theory kicks in. The chosen B cell is selected and gets a powerful activation signal. It begins to clone itself. It divides rapidly, making thousands of identical copies with the same key. From one detective to an entire army in days. Your body amplifies its response. A targeted fighting force to take down that invader. It's genius. So, you now have an army of cloned B cells, all primed and ready to fight virus X. But what do they actually do? Instead, they transform into something even more powerful: plasma cells. You can think of a plasma cell as a microscopic factory whose sole purpose is to mass-produce weapons, and the weapons they produce are called antibodies. These antibodies are essentially tiny, free-floating versions of the original B cell's receptor, the keys without the rest of the cell attached. A single plasma cell can pump out thousands of antibodies per second. That's not an exaggeration. Within days, your bloodstream becomes flooded with millions of these highly specific Y-shaped proteins, all designed to do one thing: find and stick to virus X. First, this process, called neutralization, can physically block the virus from infecting your healthy cells. Second, the antibodies act like bright red flags. When a virus is coated in antibodies, it becomes a delicious-looking meal for phagocytes. This is called opsonization. Finally, the tail end of the antibody can trigger the complement system, which can literally punch holes in invading bacteria. So these antibodies don't just identify the enemy, they actively participate in its destruction in multiple ways. They are your guided missiles, locking onto their target with incredible precision. This massive wave of antibodies is what truly turns the tide of an infection. From a single B cell recognizing a threat, you now have a full-scale, body-wide counterattack underway, all thanks to the B cell brigade and their incredible antibody factories. While B cells and their antibodies are amazing, they aren't the whole story. They're fantastic at fighting invaders that float in fluids like blood or lymph. But what happens when a virus gets inside one of your own cells? Antibodies are just too big to get in there. To deal with this, you need a different kind of soldier, a specialist in close-quarters combat. You need the T cells. The T cells are the other branch of your adaptive immune system, the Special Forces Task Force. There are two main types of T cells we should know about, and they have very different jobs. First, there are the helper T cells. These are the generals and field commanders of the immune army. They release powerful chemical messengers called cytokines that act like battle commands, telling B cells to produce more antibodies and calling phagocytes to the site. In fact, HIV specifically targets helper T cells. By taking out the generals, the virus can incapacitate the entire army. The second type is the killer T cell, and its name tells you exactly what it does. Your cells display little pieces of what's going on inside them. If a cell is infected, it will present viral fragments. When a killer T cell finds a cell displaying enemy fragments, it delivers chemicals that tell the infected cell to self-destruct, destroying the virus factory before more viruses can be released. It's a tough but necessary job to save the city. Here is one of the most remarkable parts of this whole process. After the battle is won, after Virus X has been cleared from your system, the war is over. Most of the cloned B cells and T cells that were created to fight the infection are no longer needed, and they die off. But not all of them. A small number of these battle-hardened veteran cells stick around for the long haul. These are the memory cells. They are the living record of the battle you just won. They continue to circulate in your body for years, sometimes for your entire lifetime. They're like a highly experienced squad who know the enemy inside and out. If Virus X tries to invade again, it will be met by a whole team of savvy memory cells, ready and waiting. The response is faster, stronger, and much more effective. Often you won't even feel any symptoms. The virus is wiped out before it can gain a foothold. This principle of immune memory is the fundamental science behind vaccines. A vaccine works by introducing your immune system to a safe, harmless version of a germ. Dead virus, weakened virus, or a small piece of the virus. It's not enough to make you sick, but it's enough to trigger this whole process and create memory cells. It's like giving your security team a training manual and running a drill for a specific bad guy. Have you ever wondered why you get sick less often as an adult than you did as a kid? This is a big part of the reason. The second time you encounter the same germ, the response is faster, stronger, and more effective. So your immune system has learned, it has adapted, it has made you stronger. But what can you do to help it be at its best? Now that you understand the incredible intelligent army inside you, the next question is obvious. What can you do to help it? How can you make sure your immune system is in peak condition, ready for any challenge? It's easy to imagine you need some expensive supplement or complicated biohacking routine, but the truth is far simpler. Before we get to the practical tips, just pause for a second. Think about a time you were really run down, stressed out, and not sleeping well. When your body is under stress, it produces hormones like cortisol, which can suppress the effectiveness of your immune cells. The power to support it is in your hands every single day. First, supplies. Next, rest. Finally, movement. Let's break them down. Your immune cells are constantly being produced and need raw materials to be built correctly. A balanced diet rich in vitamins and minerals is like providing your army with the best equipment. Vitamin C, citrus fruits and broccoli, helps phagocytes function. Vitamin D, skin exposed to sun helps regulate immune responses. Zinc, nuts and beans, critical for T-cell development and function. Sleep is essential. While you are sleeping, your body produces cytokines that coordinate the immune response. Aim for 7 to 9 hours per night and add regular moderate exercise to improve circulation and immune patrol. We've been on quite a journey, haven't we? We've seen how your body survives a deadly threat. We've met the security team of white blood cells and uncovered the elegant secret of clonal selection. We've watched B cells become antibody factories and witnessed T cells lead the charge. We've learned that our immune system has a memory, getting smarter and stronger with every battle it wins. Understanding this doesn't just satisfy curiosity, it gives you power. It transforms you from a passive passenger into an informed and active partner in your health. Knowing that sleep deprivation weakens your T cells makes choosing to go to bed on time an act of self-defense. Choosing a salad over junk food becomes a strategic decision. Share this knowledge with others. Help build a collective defense that protects everyone. So here is your mission. Appreciate the miracle of your immune system. Take care of it. Feed it well, let it rest, and support it with healthy choices. Trust in its incredible ability to learn and protect you. Now go out there and be amazing.